You type a question. A few seconds later, an answer appears. It feels instant, clean, almost weightless. Like intelligence finally escaped the physical world. It didn't. We called it the cloud, which was a very convenient name for a warehouse full of heat. Because that answer did not come from nowhere. It came from chips, memory, cooling systems, substations, networking gear, and buildings the size of small towns. People think OpenAI has an AI problem. It doesn't. It has a reality problem. Because for most of the last 2 years, the thing limiting frontier AI was not ideas, not algorithms, not even money exactly. It was whether enough of the physical world could be assembled fast enough. The comfortable answer is that AI is running out of GPUs. And that is true. But it misses the part that matters. A GPU is not one object. It is the visible tip of a much larger chain. The chip has to be fabricated, then paired with high bandwidth memory, then packaged, then shipped, then installed, then powered, then cooled, then networked. If any one of those steps fails, the AI breakthrough never leaves the building. That is the trick of this whole industry. The software gets the headlines. The bottlenecks are almost always industrial. Take memory. Some of the most important AI memory in the world was effectively spoken for before most people even learned its name. That's how weird this gets. The shortage isn't always the glamorous part. Sometimes the future gets delayed by the microscopic layer wrapped around the glamorous part. Then there is packaging. You can have the chip design. You can have the money. You can have customers lined up around the block. And you can still be stuck waiting because the final high-end packaging step is jammed. That is like building a Formula One car, then discovering the whole season depends on whether someone can find enough lug nuts. Then you hit cloud capacity. In 2024, OpenAI had to reach beyond Azure and use Oracle for more capacity. By 2025, it added Google Cloud too. That is not what software companies do when everything is going smoothly. That is what they do when the machine underneath them is straining. That's the first big clue. OpenAI stopped looking like a model lab, renting infrastructure. It started looking like a company trying to piece together an industrial fleet from whoever still had room. And then the story gets heavier, because AI does not live in the cloud. It lives in buildings that eat electricity, not use electricity. Eat it. When people say things like 10 gigawatts, your brain is supposed to go quiet and nod politely. Don't let it. 10 gigawatts is roughly the power draw of about 10 million toasters running at once. That is not a software number. That is a grid number, a substation number, we need land, permits, transformers, and cooling towers number. At that scale, OpenAI stops sounding like a chatbot company and starts sounding like a utility that accidentally learned to write poems. And this is where the story gets almost comical. The smartest software in the world is now being slowed down by some of the oldest problems on Earth: land, metal, electricity, and concrete. Even if you have the chips, you still have to keep them alive. These machines burn power and turn it into heat so aggressively that the data center around them starts looking less like an office and more like life support. Then comes the part nobody outside infrastructure thinks about. The plumbing, fiber, switches, optics, interconnects, the digital roads between the chips. You can own the world's most expensive accelerators and still watch them sit there doing nothing because one part of the digital plumbing failed. OpenAI's own 2026 networking work made that painfully clear. At very large scale, failures and congestion can waste compute just as surely as a chip shortage can. That means the bottleneck is no longer just, do you have enough chips? It becomes, can you keep all those chips busy? Can you reroute around failure fast enough? Can you stop one broken path from stranding an entire training run? And now the real shape of the problem appears. OpenAI is not just buying compute anymore. It is being forced to orchestrate compute. That is a very different job. Because once you start designing your own chips, negotiating across clouds, thinking about power and land, and publishing networking systems research, you are no longer acting like a pure software company. You are becoming something closer to a hyperscaler with an identity crisis. That is why the custom chip story matters. Not because custom silicon instantly saves OpenAI, but because it changes leverage. If you can eventually build more of your own stack, you stop being just another customer standing in line for the same scarce hardware. And some of OpenAI's biggest rivals started this transition much earlier. Google already had cloud fleets and custom chips. Microsoft already had enormous infrastructure and its own silicon programs. NVIDIA didn't just sell chips, it shaped the whole ecosystem around them. OpenAI came in with brilliant models, but weaker physical control. Then there is the hidden shortage. People, not users, engineers, chip designers, data center operators, network specialists, electrical workers, the humans who can actually make all this real. The AI boom is so physical now that it needs not just coders, but builders. The future is being held up by the same kinds of labor shortages you would expect in energy, construction, and heavy industry. And that leads to one of the strangest images in the whole story. You don't scale frontier AI by buying more servers. You scale it by getting 4 gates to open at the same time. Land, power, construction, equipment. Miss one of them, and the whole thing waits. That is what projects like Stargate really mean. Not just more compute, a deeper shift. OpenAI openly moved from talking about models to talking about land, power, construction, equipment, and giant campuses. That is a different species of company than the one most people still imagine. And the first symptom of this strain is not always cancellation. Usually it looks smaller than that. A feature rolls out to pro users first. Usage limits stay tight. Quotas move around. A faster, cheaper version is promised later. That is exactly what happened with deep research, which OpenAI itself described as very compute-intensive. And when image generation exploded in popularity, Sam Altman said the company's GPUs were melting and rate limits appeared almost immediately. That is the important thing to understand. The product can still look smooth on your screen, while the machinery underneath it is straining. That is how infrastructure crises usually work. You don't see the pressure directly, you see the coping strategy. And the coping strategy here is expensive. So expensive that the numbers stop sounding like software budgets and start sounding like industrial policy. Hundreds of billions for infrastructure, gigawatts of capacity, millions of chips. This is not a startup scaling story anymore. It is a civilization-scale procurement story. That is the real shift. OpenAI is moving from model lab to infrastructure operator, from renting scarcity to trying to shape it. And that shift has a ceiling, not a glass ceiling, an industrial ceiling. A ceiling made of chips, memory, packaging, power, data centers, networking gear, and skilled labor. That is the mechanism behind this whole story. The infrastructure ceiling. The limit is no longer just how much intelligence you can invent. It is how much reality you can assemble. Because AI is not one invention. It is a chain. A foundry chain, a memory chain, a packaging chain, a power chain, a cloud chain, a networking chain, a labor chain, and the final answer on your screen is only as strong as the weakest link behind it. But you never see that part. You still just see a text box, a prompt, a reply, something that feels light enough to float. And that is why the word cloud was so useful. It hid the factory, it hid the substations, it hid the cooling towers, it hid the racks, the shortages, the packaging lines, the power deals, the worker shortages, the land grabs, the enormous buildings quietly swallowing electricity behind the screen. People think AI arrived as software. It didn't. It arrived as infrastructure wearing a software mask. And once you see that, the whole industry looks different forever.